So we can express using the division algorithm. So you know, you can see it's all coming together now, somewhat. So we can rewrite A in the following form. A is Q1 n plus R1, right? And we know, let's see, that R1's got to be less than n, okay, from the division algorithm. And similarly, B will be, what do we call it? Q2, or let's say Q2 n plus R2. And R2 is going to be satisfy this. Right? That's from the division algorithm that we did earlier. Okay? Now we're told, because that's statement Q, right? We're assuming Q is true, we're assuming this is true, and we're trying to prove this. And what does Q say? It says that these two remainders are equal. Okay? So from Q, we know that R1 equals R2. Right? We're told that. So they have the same remainder. So R1 and R2 are the same. Okie dokie. So therefore A minus B. So we're heading towards this now, because the definition of congruence involves A minus B. So now we know what A is, we know what B is, so we can find the difference. So A minus B is, well, you just plug in that minus this. So that's Q1n plus R1 minus Q2n plus R2. Okay. And that comes out as, take the n outside, so it's Q1 minus Q2 n plus R1 minus R2. Okay? Alright. Alright, we're doing the if part. We're assuming Q, so this is true. Now, R1 equals R2, so that cancels, and therefore A minus B is some integer times n. So that means n is a factor of A minus B. Okay? So that means n divides A minus B. So that implies n divides, divs, n divides A minus B. And that's the definition that A and B are congruent, mod n. So that implies that A is congruent to B mod n. Right? So we've proven the if part. Okay, now how to go the other way. So if we start with, so the only if, that's from P to Q, from left hand side to right hand side. So we start with this and we have to prove that the remainders are equal. So how do you do that? Okay, so we start with this, right? So that means that A minus B can be divided by n, right? So that means that you can write A minus B in the following form. So n's a factor, right? So we'll put some other integer. So you can write A minus B in this form, because you assume this is true, right? A and B are congruent modulo n. So that means that n divides A minus B. That's the definition of congruency. Okay, so you can express A minus B in this form. There's the factor, n divides that, so it's n times some other integer. Okay, so we've got, that's true. Now this this is still valid, right? That's true in gen. Oh, wait a minute. Yeah, this is general. Right? This is just from you can express A in terms of n or B in terms of n. That's just the division algorithm. So that's general. And from that, A minus B will take this form. And we're trying to prove that these two are the same. So for the moment, that's, we won't kill it. It's still there. All right. Now, so let's rewrite this. So I'll put it down here. So Q1 minus Q2 n plus R1 minus R2 equals, AB is nk, and AB is all this. So this, which equals A minus B, but A minus B is nk, so we just put nk here. Okay? Now, remember these two. Now, here's where you need a bit of analysis. So I'll just write the result down, and then I'll try to justify it to you. And again, I need a bit of space. So let's see. Okay. Yeah, I'll just throw it at you and then try to justify it. Now, oh, dang. So R1 is going to be less than n and greater or equal to 0. And similarly for R2, right? That comes from the division algorithm. Now, if those two are the case, you can derive the following. So minus n is less than R1 minus R2 is less than n. Now from these two you can derive this. Now that may not seem obvious, so let's I'll try and justify why it's the case. Alright, well now so this should be R2. Okay. Now, what's the biggest this could be? Well, if R1 is almost n, right, and R2 is almost nothing, right? So if this is almost 0 and this is almost n, then this difference is almost n. Okay, so n's the limit. Now, what's the smallest this could be? Well, what if this one's almost 0, right? If R1's almost 0, or if it is 0, then this is almost n. So that would make this difference almost minus n. Does that seem plausible? Okay. So think about it. Given these two, from these two, you can deduce this. Okay, and so let's assume this then. Now, so that takes us. So this difference here between the two residues, the two remainders, it lies between, strictly between minus n and plus n. Okay? Alright, now let's rewrite this a little bit. So let's rearrange this. So R1 minus R2 is equal to nk minus, you just take this over, so this will be minus Q1 minus Q2 n. Okay? Now look at this right hand side. This is a multiple, a multiple of n. So k minus Q1 plus Q2. So this is just an integer. Now, these are all integers. So the right hand side is just a multiple of n, some integer times n.